Is the screen shared or it's not shared? Okay. It's showing, right?
Yep.
Okay. So this is week 7. After week 7, you have 2 weeks break. You got plenty of time to do your assignments. Make sure you try to complete a proper part of your assignments in week 8 and 9, which is holidays for you guys. I will resume after 2 weeks. In this time, you can take your all your questions related to first 6 weeks. First 5 weeks, literally, you can build your own application. Regarding week 6 Angular, you can create a standalone Angular application, or you can integrate it with a Spring Boot based microservice, which we will learn later in week 9. So you can or you may not, but week 1 to 6 is quite sufficient for you guys to create your project. So that's done, and you should be in a position to create your projects. For people targeting HT, you need to demonstrate web services, and you also need to demonstrate and development of an Angular application. You can take cue from a Pokemon Angular app and demonstrate something similar related to, instead of Pokemons, be it contact persons, a list of contact persons, and likewise. So it's all up to you. That's a good question. If we have consultation time in the break week, I don't think so, but yeah. Gwen, can you confirm that?
Yeah, we will so run 5 to 6 consultations.
Okay.
Yeah, so each week, right? Each week, yes.
So do you mean we'll have regular consultation during?
No, it's not regular. So we'll probably come up with some other times, but it's probably the totally totally five maybe 5 to 6. So we have a limited time during the mid break.
All right, you'll publish it.
No, I haven't published it. So we need to discuss this during our meeting. I think then I will publish it.
All right, makes sense.
Yeah.
All right, so Gwen will let you guys know when we are going to run the consultation, who is going to be in which consultation during this week. So you're creating an enterprise application using JSF, and you can also use Angular application. This is for the people who are targeting HT. Anyways, this is weekly material. So introduction to Spring MVC. Along with Spring MVC, I'll just keep my lab notes. The other one's open as well. So there's an additional study material provided to you. That's a little bit more like a regular study material for notes. And this is a lecture part. This is the tutorial exercises part. So, okay, this is the tutorial part. Okay, for the tutorial part, this is very simple. This is like an hello world of Spring MVC. You don't need any starter files for this exercise. Okay. The two objectives for this lab is to keep your environment ready for CRUD operations, transactions management in week 8. And the other part is to just run a demo web application using controllers, models, and just a starter JSP page. So these are the steps mentioned how to create your Spring MVC application. At some point of time in today's lecture, I will run through them. But the first prerequisite, even for week 1, is to install the application server, Tomcat. Tomcat is your similar to that of a Glassface. Glassface is also a web server. Tomcat is also a web server. So in this, in IntelliJ, we'll be using Tomcat for our work. All right. I will touch base on these parts during the course, but this is for everyone to understand. You'll be running your projects on Tomcat, so you need this part done first, and then you can do this, and then you can come back and do installation of Maven and install MySQL and a workbench. All right, Spring MVC. So Spring is a lightweight application framework where you can have other technologies and other frameworks combined together as well, such as struts, webwork, and others. They can also be considered as a web framework. Spring addresses all tiers of an application, be it the client side or be it the middleware or be it the database side. So in the middleware side is the main component similar to that of Phases servlet you had in JSF. So Spring has something similar which is called as dispatcher servlet. We'll learn a little bit more about it. The beauty of Spring is that Spring is a lightweight framework and everything works by simply referencing what you want to use as a component and just simply referencing that in your web XML and in your web context, a web application context, you'll be able to use varieties of technologies using Spring, okay? So Spring has some core technologies that work with Spring. In fact, in week 9 and 10, you'll be learning Spring Boot. Even for that, these technologies are very core and common because you'll know how they are very much an inherent part of it. So you need to understand few concepts like what is IOC, that is inversion of control, what is dependency injection, what is auto wiring, what is aspect oriented programming, and what is MVC. So our focus on the later half will be more on the MVC side, but these three is very central, very core to that of Spring, and they are very much confusing and interlinked. So you need to understand their differences very clearly. Okay, so auto wiring, DI. By this time, I'm conscious that you guys are aware of what is dependency injection. All right, and IOC is inversion of control. So dependency injection happens by virtue of IOC. Okay, but we didn't discuss IOC in depth when we discussed annotations that did dependency injection. The reason was that the return was not going to a framework container. It was all inside that framework container. So we were not discussing IOC during dependency injection, but for Spring, it is inherent because Spring is this lightweight framework. The Spring container encompasses all the application layer, and when there is a dependency injection, by virtue of inversion of control, dependency injection happens, and dependent object been returned to a Spring container, and that's how this is essential to understand. And then auto wiring, uh, which is like, instead of explicitly creating an object inside a class, auto wiring a reference will implicitly create a future object inside your class. So that's auto wiring. But auto wiring is slightly different from dependency injection. And how we'll see in the coming slides. And then there is aspect-oriented programming. So aspect-oriented programming will not be doing much on this, but it is something that you should know. If you have a transaction processing system, you can actually modularize a particular piece of code as an aspect, and then you can have joint cuts and point cuts to run a function when in between, when especially an aspect has been called. And then finally is your MVC, the model view controller part of Spring. It will be very fun to see how to build a CRUD operation in week 8. That is 2 weeks after today. Sorry, this week. But we'll see how it comes. So the first one is IOC, inversion of control. This is the single most important concept of Spring framework. IOC underpins a lot of functionalities provided by Spring. Traditionally, the control of logic, relationships, and the flows are usually defined and maintained within the application code. In the IOC world, control is handed over to the Spring framework, which calls the application code instead of application calling the framework. So the control is with the Spring container, with the Spring framework, which calls the application code instead of application calling the framework. So this is possible because of IOC. So in Spring framework, the objects that are instantiated and managed by Spring IOC container are referred as beans. And these beans, together with the relationships and dependencies, are defined in the configuration metadata used by the container. So these beans, you can define it in the configuration metadata XML, or even you can define it in the class. There are using annotations. There are multiple approaches. So in the older days, they used to do it using XML format, but nowadays it's all annotation based. We'll see. We have examples of both. And then you have dependency injection. So dependency injection is tightly coupled with IOC. I was talking to you guys about this a few moments back. These two are very much related. So typically, multiple classes, they work together to perform a certain task and are interrelated with each other in some sort of relationship. Instead of defining the relationship with the application codes, this kind of dependencies can be defined in XML metadata configurations or using annotations. And the container will be responsible to inject the relationship when the bean is created. To give you a better idea of it, let me open a Jamboard. So So dependency injection happens by the virtue of inversion of control. So I'll just create one. So if you have a class A that references class B and class C, like A is referencing class A and class B and C. In that case, we are injecting the dependencies of B and C in class A, where we don't configure these classes in uh, in the class where it is created. It is configured somewhere else in some other environment. So that's dependency injection. So by the virtue of which these dependent objects are created and being returned to the calling parent environment. In Spring case, it is always returned to the beans which are created are always returned to the Spring container. So by virtue of which the objects, configured objects, are returned to the container back, is called as IOC. So this is so one side of relationship is dependency injection. The other side of relationship is IOC. Okay. And then third comes auto wiring. So auto wiring, you can be easily confused with what is auto wiring, difference between auto wiring and dependency injection. Well, auto wiring is when the Spring IOC is able to auto wire relationship between collaborating beans. So be it a controller, service, or any other component, where I'm able to implicitly use another class, okay, instead of explicitly uh, mentioning it. For example, if I have a class A and then I auto wire, let's say customer, right? Customer, and then customer has something called as address, okay? So if I want to use address and there is a separate object called, separate class called address, okay? And I want to use address as a part of my customer. So I can simply use @AutoWire address. So what happens is that if you have functions and methods here in the address class, simply by using address, I will be able to use those functions rather than writing those functions myself. That is AutoWire. Uh, so there is a difference from AutoWire and uh, dependency injection. In dependency injection, you usually provide out the reference and initialize things, whereas so when that initialization happen in dependency injections, they are configured elsewhere, okay? But when you auto wire something, they are implicitly present, okay? You don't have to explicitly do any kind of configuration or things like that, okay? The configuration and everything is already taken care by the Spring container by virtue of IOC, inversion of control. So these three concepts are very much interrelated and very tricky, but they have very substantial boundaries. So Spring IOC container is able to auto-wire relationship between the collaborating beans. It means the container will automatically resolve the bean relationship by inspecting the factory contents. Auto-wiring in Spring happens at a bean level, which means it is possible to auto wire some beans in the container and not others. Okay, not all beans are configured. Not all beans can be auto wired. Some beans can be auto wired. And the advantage of auto wiring is that it saves a significant amount of typing and maintenance effort for developers. We will have some classes auto wired in week 8 lab. Okay, so we'll have examples of dependency injections and auto wiring in the week 8 lab. But these are the basic things you need to understand. So aspect-oriented programming solutions are applied to those enterprise concerns such as transaction management, which have traditionally been addressed by EJB. The goal of aspect-oriented programming support is to provide J2E service to POJOs. Spring AOP is portable between application servers. It works either in web or EJB containers. But the main takeaway for you guys to understand is aspect-oriented programming is for transaction management. Suppose if you have a flow of transaction and you have series of calls and like that, you can simply use you can create modularize your transaction managements or your applications. You may have multiple ways of doing transactions and everything, so you can modularize them and use different aspects. So you can use aspects using @aspect, and using @aspect you can have point cuts and joint cuts. So you can probably use these point cuts and joint cuts in between your transactions to call different other functions. So this is done majorly like logging services or even alerting, things like that. So there is a listener that will be running at point cuts and joint cuts if you have an aspect, and this point cuts and joint cuts will call out to these listeners, and you may execute other methods based on it. So that's aspect oriented programming. All right, so now the main part, the MVC, model, view, and controller. So the Spring MVC framework provides model, view, controller architecture. So the components to develop flexible and loosely coupled web applications. All right, so separating aspects of the application, that is input logic, business logic, and UI logic, while providing a loose coupling between these elements. So this is Spring MVC framework. It again, it's very similar to that of your JSF, but it has its own lightweight container doing inversion of control, dependency injections, and things like that. It has its own component to run the web applications. The benefit is that Spring MVC is a very loosely coupled web application. That means if you want to make changes in the UI, you just have to update a JSP and other. So like if you're using Spring, you can use JSF technology along with Spring. You can use JSP. You can use any other view templating languages along with Spring. That's the beauty of using a lightweight container like Spring. Okay, and then you can also have a separate layer to do so you have model, view, and controller, right? So model is something which is inherently provided as a component by the Spring framework. So the view is basically based on the views or the JSP pages that you create. Controllers are the one that you create. So model, controller, they're all beans. Bean components, we call it in Spring. You can configure it in the XML, or even you can create your own controller classes. The separation of logic happens is that you have views that has been controlled by a different controller, but the parent controller is a dispatcher servlet, something very much similar to that of your Faces servlet. We'll look at the architecture in the coming in the coming slides. Right. The model encapsulates the application data, and in general, they will consist of a POJO. View is responsible for rendering of the model data, and in general, it generates an HTML output that the client's browser can interpret. Okay. Controller is responsible for processing user requests and building appropriate model and passes it to the view for rendering. All right, so this is something you're familiar with. So this is the main architecture of Spring Framework, where you have dispatcher servlet. So any request coming in is intercepted by the dispatcher servlet. Okay, so you have an HTTP request coming in. So dispatcher servlet gets that request first, and then it tells to the handler mapping, hey, I got this request. What do I do with it? Handler mapping says, for this request, call this bean, call this controller bean. Okay, so then it will pass that request to the controller, and controller is responsible to create the model and and it passes the name of the view. Okay, so controller is very similar to that of your EJBs, and not EJB, is the managed bean. Okay, so controller is similar to that of a managed bean. It controls the navigations of incoming request and response view. Along with that, it creates the model that needs to be associated with the view. In your JSF technology, for your managed bean, you were creating the attributes that are displayed on the view on a managed bean. However, there are three kinds of model that you can create in a controller. That is model, model map, and model view. Using these three kinds of model, which is basically to hold the variables or the web template values that are to be displayed in a view. So this controller, the counterpart of the controller in JSF is managed bean. So this controller may have a backing call to service methods, which is not here, but controller will be calling some service methods. Okay, so this service method acts as like EJB. So this is like managed bean, and this is like EJB. And this service methods, they will be able to connect to a database using DAO layer. All kind of logic implementation must happen in these service methods. Okay, if required, this service methods would call the database and get the value back, process the business logic, and provide the details back to the controller. In the controller should be able to update the model and provide the name of the view to the dispatcher servlet. So, so once it provides it to the dispatcher servlet, that happens through IOC. Okay. So once it provides it to the dispatcher servlet will look at the name of the view and pass it to the view resolver. Okay. So in view resolver, it will tell, okay, this view name, you can find it in this specific location with this specific extension. And then it will go and fetch the view. Okay. So once it fetches the view, it will update the view with the model that has been returned by the controller. And then the response will be sent back. So this is an architecture of Spring. So in this specific slide, you have that the sequence of events corresponding to incoming HTTP request to dispatcher servlet. So after receiving HTTP request, dispatcher servlet consults the handler mapping to call appropriate controller. So once you get a request, dispatcher servlet will consult the handler mapping, and handler mapping will respond back saying, okay, this is the controller, okay, the name of the controller. And the controller takes the request and calls appropriate service methods based on get or post methods. These service methods will set the model data based on defined business logic and return the view name to the dispatcher servlet. So here you have controller calling service methods, and the service method might access a database. And database will respond to the service call. They will do business logic in the service method. And there is this is called as DAO. This service methods are called as DAO, which is otherwise called as database access objects. And these service methods are very similar to that of your EJBs. They do the business logic. They call the database access layer to get data from the database. They manipulate it and return the process data to the controller. And controller will update the based on data returned from the service methods. It will update the model data based on the defined logic and return the view name to the dispatcher servlet. The dispatcher servlet will take help from the view resolver to pick up the defined view for the request. So from here, what is returned is model. Model contains data and the name of the view. Okay. Once this is passed, dispatcher servlet says, okay, I need this view name. And the view resolver says you'll find it here, which specific view. and that view is constructed and returned to the dispatcher servlet. What dispatcher servlet does is it applies the model to the view and sends it back as a response. Okay. So this is the sequence of events that corresponds to an incoming request. So web application context, the above components, that is handler mapping, controller, and view resolvers, are part of the web application context. Okay. So dispatcher servlet is the main servlet container that handles, which is like the front controller. Okay. And the remaining controllers, handler mapping, and view resolvers, they're part of the web application context, which is an extension of application context with some extra features. Okay. So this is the flow control, the request processing lifecycle. So you have an incoming request, HTTP request. Then you have a front controller. So what is the front controller in Spring? What is the front controller in Spring? Correct, it's dispatcher servlet. And what dispatcher servlet does is it will consult the handler mappings and delegate the request to a controller. Controller will handle this request. It will be creating the model, and if required, it will call some service methods. Okay, it will call some service methods, and this service method is something similar to that of your EJB, and these service methods will call database. These are called database access objects, and once they return values, it will update the model, and based on your request and the controller that you have called, it will pass the model and the name of the view to the dispatcher servlet. And based on view handler mapping, view resolver, sorry, based on view resolver, it will get the view and it will apply model with the view and return a response. Okay. So this is the flow control mechanism. The model has to be created in the controller and has to be passed back to the dispatcher servlet. You don't do it manually passing things. This is all handled by the dispatcher servlet. So not by the dispatcher servlet, but the Spring container by virtue of IOC. So if you're injecting something, it is dependency injection. When you're returning the object back to the calling container or the environment, the framework, it is called as IOC. Okay. The same thing, the request process lifecycle of Spring MVC. The client sends a request to web container in form of HTTP request. This incoming request is intercepted by the front controller, and it will then try to find out the appropriate handler mapping. With the help of handler mapping, dispatcher servlet will dispatch the request to an appropriate controller. The controller tries to process the request and returns the model and view object in form of model and view or model map or even model. There are three types of it. We will be using all the three types in our examples. Not for this week, but for week 8. For this week, we are just using model map. I'll show you during the lab demonstration part. So the controller will return the model and the view name to the front controller. The front controller tries to resolve the view, which can be any view templating language like JSP, JSF, FreeMarker, Velocity, likewise. And by consulting the view resolver object, the selected view will be then rendered back to the client. This is a Spring MVC application. So the steps involved in creating a Spring MVC application is configure the web XML and the dispatcher servlet. Okay, so if you see in your studio notes, when you create a new project, when you create a new Spring project, you have a dispatcher servlet created. However, you defined, if you're using Spring, you'll be defining that in web XML. So in web XML, you will be saying, okay, I'll be using, so by default, the name here will be dispatcher. You can have as many servlet application running. So that means you can have 10 different application servlet running here, okay? Like dispatcher servlet, hello web servlet, application X servlet, application B servlet, likewise. So based on the name of your servlet, your name here should be updated. Okay, so I'm using hello web. So after I update hello web here, I should be able to rename this to hello web -servlet. Okay, that part is also called out here. Okay, and then comes the after the web XML part, you have configuring the servlet config, which is changing the name based on the servlet name to hello web servlet. And inside that, you can define your individual beans here. Okay, however, that's not really scalable if you want to use some more things in future. So you just say context component scan and provide the which package you're having your Java classes, and that should be suffice. Okay, and then we are not using the application context here. Most of it will be taken care on the other side. All right, this is creating your web pages, and this is Java classes. Okay. So the steps involved is first is configuring the web XML and the dispatcher servlet, then configuring the web and application context. If you have any kind of dependencies, you do it here. Then creating and configuring controller beans, then creating the view resolvers in the application context, configuring business logic and other beans like database access objects, service beans in the application context. We are not using this in this week practice, but we'll be using it in the coming week. This week, the lab is purely just an hello world Spring application and setting up the environment for week 8. we'll be also be creating some views and creating controllers. Okay, so those are different things that you need to keep it in mind when you are creating a Spring MVC application. Right. So as I was saying, you need to map requests that you want. Okay, one important thing I should mention, you guys. So by default, the controller that you create here in Spring, they are singleton. Okay, so that means the same controller is available to all requests being fired. However, there's a provision if you want to make the controller as something else. So all requests will be sharing the same controller because controllers are by default singleton. However, if you want to change the controller to a different scope, you can do it using @scope and change it to session or application likewise. For our respect, we won't be needing this, but yeah, this is if you want to further investigate or further you want to explore your knowledge. So the first thing is configuring the dispatcher servlet. Just like you use faces servlet in the servlet in your JSF projects. Similarly, you need to get the dispatcher servlet to make it as a Spring project. You need to map requests that you want the dispatcher servlet to handle by using a URL mapping in WebXML. The following is an example to show declaration and mapping for dispatcher servlet example. So I was saying by default, the name is dispatcher. You can have multiple servlet classes running and you can give it any name. Okay. So you can have Spring running, you can have JSF running, all running in parallel. Okay. That's still fine. Okay, configuration of the application context. After initialization of the dispatcher servlet, the framework will try to load application context from the file name dispatcher servlet. This is not constant. This will be changed based on whatever your servlet name is. It should be located in applications web app, web content, web.inf directory. The next is servlet mapping tag indicates what URLs will be handled by the dispatcher servlet. So let me pull up. So servlet mapping tag in WebXML, in the servlet mapping tag, your URL pattern that starts with the context root will be handled by your servlet, hello web. So anything with this pattern will be handled by this. Okay. So this configuration is very similar if you try to see in one of your Faces servlet or a JSF project. Um, so if I pull this up here inside web content and this web XML, so this is very similar. So your the servlet name is Faces servlet because Faces servlet is a parent controller in JSF. And then you have the name of the servlet and the pattern which it manages. Okay, so this is the root, which is from the context path. The context path is the name of your project, and all URL following this pattern. Here, this specific servlet that is running dispatcher servlet instead of faces servlet will take care of anything that starts with this root path. Okay, this is a servlet mapping. So here the index file is faces index.html, here index.jsp. So JSP is Java server pages. But this is very similar. And once the JSP loads, if you want to change it to a different page, so you simply, okay, that's a very good question. I'll come to that. So if you have response.send direct index.html, so it will redirect your request to some other page. And what page and everything. So whenever there is a request, right? So what is the first thing that has to be called? So when you get a new request, what was the first thing that needs to be called? So dispatcher servlet will first call the handler mapping. Handler mapping will tell which controller to call. Okay. So one of your friend has asked, what is this load on startup? Okay. So if I have, JSF running in parallel with Spring, in that case, what I need to do is I need to have so if you see here, I'm not using I haven't imported or they're not there in the library, it's missing. But here if you see when I use load on startup, it will first run the faces servlet engine, and then in the next second sequence, it will run the dispatcher servlet engine. So that is load on startup. So during startup, which one to load first? Okay. That's load on startup. You won't need it until you're running multiple servlet containers or multiple Spring projects or multiple different technologies used inside Spring. Until then, the web XML looks very simple. But when you add more and more context to it, this gets heavily lifted out. Right. So we were saying that if you have on your welcome index.jsp something that has response.send redirect, that means when the index.jsp loads, the dispatcher controller needs to send this specific page. So what happens? When the index.html request comes, dispatcher will find appropriate controller. Okay. And this is done by the handler mapping. And so this is the way in which you do it in XML. Okay. So you say when you have a request coming for this specific view, you need to call this specific controller. This part is pretty standard. This part is pretty standard. You just need to have different IDs for the same class. But this mapping is pretty consistent. So based on here, you can add multiple keys and provide different controller names. This is a little old standard XML ways of doing it, but we will actually do annotation based thing, which is a recent way of doing things. So then it will find the controller, index controller. In this case, which is index controller, here in our case, we'll find the parameterizable controller. This controller simply forwards the request to the view. So this is the name of the bin, index controller. And it says this is the name of the view. So this view doesn't have any model. So it's very clean, just the name of the view. So the best practice is to use controller classes and not to wire everything in the configuration. So we'll be using the best practices, don't worry. We'll not wire everything, all this. So these all things, what you see, right? You can put it here, okay? But we'll not put everything here. We'll use the best practices and not wire everything in the configurations. So once it gets the name of the view, it simply forwards the request to the view index, that is index.jsp, without doing any logic. And the view resolver, based on the view name, it will look in the views resolver. So this is the appropriate view name. And we'll look in the view resolver. In the view resolver, it is defined as, you will find your views in a webinf JSP directory, and we'll have an extension of .jsp. Okay. We do have this part of the configuration here. So we have it here. So you'll find all your views under webinf folder called JSP, and the views will have a suffix of .jsp. Okay, so if you see under webinf JSP, there is a folder, and then there is a page called hello.jsp here. Okay. The dispatcher servlet will be used. So here I'm using hello web servlet because I have changed the name of the servlet engine, okay, as hello web. Whatever name you use it here is the exact name that you need to have here. Okay. All right. So dispatcher servlet XML5 will be used to create the beans defined. Overriding definition of any beans defined with the same name in the global scope. The context component scan tag will be used to activate the MVC annotation scanning capability, which allows to make use of annotations like controller and request mapping. Okay. So we have it here in our Hello Web XML, the context component scan. We have kept all our controllers here under com.controller. So controllers will have an annotation at the red controller, and the controllers will have what request coming in as such. So this is kind of request that is coming in here. This kind of request will call this specific method of this specific class. This is a very simple one. We'll have much complex ones in week 8. Okay. So this tag will be used to activate the annotation scanning capability to which allows the use of annotations like controller and request mapping. The internal resource view resolver, which I just showed you here, internal resource view resolver, will have the rules to define, resolve the view names. So as per the above defined rule, a logical view name hello is delegated to a view implementation located at webinf JSP hello.jsp. So what it's saying is that based on what is here, so based on the name of the view as hello, so if a logical view name hello has to be delegated by the view resolver, it will suffix this, sorry, it will prefix this, and then it will write here hello, name of the view, and then it will put the suffix next to it. So that would be the name of the view located in this directory under webinf. Okay. This is what is shown here. If according to the above rule, if a logical view named hello is delegated, that implementation method will be located here. Cool. So you have controllers. So it's 7:10. Do you guys? So I have got a few more slides. I can finish the lecture by 7:30. So I'll not give you a break now. I'll just sprint and finish it 30 minutes early. Does that sounds good to you guys, or you need a break? Okay, we'll finish it up by 7:30. We'll sprint. Okay, cool. So you have a controller. So dispatcher servlet delegates the request to the controllers, which we saw in the beginning, to execute the functionality specific to it. So controller uses annotation @controller, which indicates that particular class serves the role of a controller. Controller is similar to that of your, what is a counterpart of controller in JSF? Very good. It's a manage pane. So controller annotation indicates that a particular class serves the role of a controller, and at the request mapping annotation is used to map a URL to either an enter class or a particular handler method. So if you have annotation like either a request mapping on top of a class, that means this class will be called whenever there is /hello. And then if you put another request mapping path here /xyz, then this method will be called when /hello/xyz is called. So if you see here, the model is injected here in the controller method. So injection happens in multiple ways. This is called as setter injections. So in setter injection, the model is, so when this method is called, this type of a model map is created. So I was saying you, this model is of 3 types: model, model map, and model and view. So the request mapping directs a URL to an entire class or a particular handler. particular handler method. So here, if you look for a path like /hello, it will call up this specific method. In the model, in your manage pin, you are creating individual attributes, right? But here, you just create the model. Controller creates the model, and you can add the attributes, whatever you want to display in the view here, like a key and a value. Okay, this is model map. Map consists of a key and a value. You can have many attributes here. There's a simple one value here. There is a you can add as many attributes you like. Okay, and then it returns hello. What is this hello here? Who can tell me? What is this hello? What does the controller returns? So whatever dependency injection of the model happened here will be returned to the dispatcher servlet by virtue of IOC. So whatever DI happened here in this method will be returned to the dispatcher servlet by virtue of IOC. It will get the model back from the controller. What else the controller needs to provide? Correct, it provides the view name. So this hello is the name of the view. So model, so based on the business logic defined, you'll create a model within this method. You can you set different model attributes, and these attributes will be accessed by the view to present the final result. The example creates a model with its attribute message. Defined service method can return a string which contains the name of the view. And in this example, it is hello. So the last is the view part. So this is the controller. This is the model. And this is not the parent controller. This is just a view controller. The parent controller is dispatcher servlet. And then this is the view. Hello is the view. The Spring MVC supports many type of views for different presentation technologies. These include JSPs, HTML, XML, velocity templates, XSLT, JSONs, and it has integration with JSF framework as well. Okay. So the benefits of Spring. Spring, you can effectively organize middle tier objects, whether or not EJB has been chosen to use. Uh, Spring takes care of plumbing that would be left up to the developer. If your C uses struts or any other framework geared to a particular J2E APIs, Spring's configuration management service can be used in any architectural layer in whatever runtime environment. So this is important. Spring configuration management can be used in any architectural layer. Spring can eliminate increase of singletons. Spring can eliminate need to use variety of custom property file formats, handling consistent way of application and projects. And likewise, so there is a list of all benefits. Spring can facilitate good programming practice, reducing the cost of programming to interfaces rather than classes, almost zero. Applications built using Spring are very easy to unit test. So if you go visit this nodes, there is there is some detailed list of the benefits of Spring, and this it has a comparison of usage of Spring framework and EJBs. You can compare. So where you need to use EJB, where you need to use Spring. Uh, I think the best reason why some of the architectures have moved from EJB to Spring is EJBs are very much monolithic in nature. Monolithic means it's just one tightly coupled application framework, and it's very difficult to scale monolithic architectures. However, Spring is more like microservices pattern based. So if I want to scale one specific component, then I can scale that specific part. And Spring is lightweight. I can configure, I can overlay different architectures in Spring. And EJB is integrated through JPA for persistence. In Spring Framework, I can use JPA, I can use Hibernate, I can use JDBC, IBET and other things. In fact, for the second project, we will be using Hibernate framework to persist our data using JPA and Hibernate. And then state management, indirect support, dependent on web container sessions. So there are some areas where you would prefer to use EJBs, and some areas where you would prefer to use Spring. So there's a detailed thing. This part is important from your exam as well as your understanding point of view. Okay, in what areas what stands out. Okay, so if you have this kind of a situation, in that case you'll probably use EJB. If you have uh, if you have something like scheduling, alerting, automated, you'll probably use an EJB because EJB provides timer services. Whereas in Spring, you need to configure quars for scheduling and things like that. Sorry. Uh, so yeah, so this is the jinx of everything. Where to use Spring, where to use EJBs. Okay. Uh, so the complexity with Spring was that in earlier version of Springs, there was a lot of configurations, not just gluing things, but gluing components and resources. However, this part is overcome using annotations. Uh, Spring needs advanced AOP features, which is not anyway, it's not what we are focused on at the moment. But yeah, if you like to have annotations and dislike XMLs, you can use EJBs. This is very much stateful. Yeah. So the major thing, just note and keep it in your mind, even if you're going to an interviews or anything, where to use an EJB based architecture, where to use Spring based architecture. If you need if your application is stateful and you need standardized and or a banking based secure application, you need to use an EJB. But if you want to do just transaction based with some advanced AOP features and you want to keep it lightweight, you can use Spring. Okay, and then yeah. So just go through this note as well. Most of it is already part of the lecture slides, so that won't be much of difference. So this is all provided there. So this part you just always remember. EJB's applications are monolithic in nature, and scaling of middleware becomes a big issue in enterprise environment. Spring gives you more flexibility. So that's the trade-off. Okay, so next week we'll be creating Spring MVC app. Database will be using MySQL, and the application server will be using Tomcat. Okay, and we'll be doing a card operation. You'll see how easy and simple it is when you compare with JSF and EJB. Okay, for that you need to wait till you come back from the break. Now let's jump into the studio part. So I have made this as a Spring project. So what you got to do is you just have to create a simple, create a new project and select Spring here, choose Spring, and yeah, so whatever dependencies are required, it's been provided here. So you need to choose, okay, just a second, cancel. File, new project. So just use Spring, Java EE, web application, and choose an application server, and choose whatever server that you have. So I'm using Tomcat 9.03. You can download Tomcat in your system and run it. So, okay, the first thing is Tomcat. So before you start anything, you just need to do install Tomcat. So for people using Mac, it's very simple. And for people using Windows, you can simply look for install Tomcat in Windows. Okay, so simply use this. Okay, some people don't have that option. Okay, I'll come back to, because people will lose context if I just look at my chat window and speak. Give me a moment. Okay, so you can simply use this to run Tomcat on Windows. So there is a question in the chat where people they don't see this option of Spring here. So that might be because you are using some version of the editor, which should not be a problem. You can use this link that I'm sending you. You can create a Spring from initializer file, or if you want, you can create a Maven project as well. We'll be telling you how to create the Maven project in the coming week. So, sorry, in the next week, which is week 8. So you can use a new project, and you can choose this, okay, and use a Spring initializer and create one. But if you feel difficulty, don't worry. We'll tell you how to create it using Maven in the coming week. But feel free to use the options. So if you see, my IntelliJ is ultimate version, and you can in fact register yourself with the IntelliJ. It's free for Monash students. You need to register using the all IntelliJ ID, WebStorm, IntelliJ, everything is free to Monash students if you register using @monash.edu. So you can use ultimate versions and not the community version. However, even community versions are also still fine. So first you need to have an editor. Second is install Tomcat. So once you install Tomcat, you should be able to do next, and once it is running, run Apache Tomcat, you should be able to see localhost 8080 and this specific page, okay? If you are running a Glassfish server or something that already runs in 8080, in that case, you might go to server.xml and change the port in default port in which Tomcat runs. I think there are a lot of links where you can find it out what to do, where to change the server.xml. It's pretty simple. It's no big deal. Yeah. And for the people using Linux, it's pretty simple. Just download the installation package from Apache. Make sure you go extract that file and change everything under the bin directory as executable. And once you make that, go into bin directory and run startup.sh. I think this is all mentioned here as well. So you have some of the details here. So once you start that, you should be able to visit localhost 8080 and see this page. Okay, so you want to shut down Apache, just do bin shutdown. All right. I want to change the port, open server.xml under conf and change it to some other port and restart. That should be fine. All right. So this is where you install Apache Tomcat. Similarly, for the database in the coming week, for the Linux user, you can use this. For the Mac, it's little difference. So there are two software here. One is the MySQL, is the database. Another is the Workbench. So Workbench is basically like a interface to see what's there in MySQL. The commands and everything will be a little different. You can see the references here. There will be something similar to this. Okay, so you can use that link and what's shared in the email, sorry, in the chat window. Okay, other things that you need to install is Maven. You can see how to install Maven in Linux and how to install it in Windows. So that's is prerequisite part for the next week. So this week we'll just run the project. I'll show you. So I usually create different instance for different projects, but you need not. You can simply choose the server that you have and run. So you just need to choose edit run configuration, choose the Tomcat server. I just create additional instances. You don't need to. Okay, that's not compulsory. But yeah, up to you. And then run it from here. or you can start the server and create project and run it. It's the same thing. So once this runs, is it starting? Yeah, it's starting. Once it runs, you will see when it runs. Just hold on. Is it running or not? Okay, it's taking a bit of time. My system is 4 or 5 years old. It's very slow. So it's deployed, which is good. You can check the Tomcat logs, and it actually opened in one of my other window. I can just it will open up this. Okay, so what you see here is hello web. Hello, this is default page for Spring Web MVC project. So this is what you see. The index.jsp, this is because you have provided that as the welcome file list. You see the title as welcome to Spring MVC project. This is the title. This is the title. Welcome to Spring MVC project. And then you have something called as hello. This is default what has been displayed here. And then click here for hello controller. This is what is mentioned. Click here for hello controller. And then you have page context context path. So it consists of the server name, port in which it is running, and the context path, which is something you would have seen in the edit run configuration. So before you run your project, you need to open up your project settings. Yeah. So if you go to module settings under your project, select Java, click on Java, and click on source. It will make the folder under Java as the source folder, and then you can on the run configuration. That's my context path. Okay, on the URL you would have provided there. Right, so that's the application context path. So that's why you are seeing this here. And then on clicking here on the application context path /hello. So if you see down below here, it says application context path /hello. So when I click there, I'll be taken to /hello, root /hello. So what happens here is it will intercept the context controller. So my controllers are present here. All right. So, okay, this is the request, and this controller needs to be called. Your servlet said you need to scan component scan COM controller for that. That's how we reached here for this specific request from the context path. Okay. And then this is a get request. And this method is called. So when this method is called, you have setter injection of the model, which is model map. Okay. And then you set an attribute on the model called message. Okay. And the value of that attribute is hello spring MVC from hello controller. Okay. And then you return the view. So it goes to the view reservoir under the servlet. It says, okay, you find the view in this part and suffix it with .jsp. So I'll display this view. So in the view, I have title as hello world. And then This is the expression language in here in the Spring. It is dollar curly braces. Very similar, right, to JSF and JSP. What is the expression language in your JSF to managed pin? And in your Angular? And what is banana notation? Okay, those things we can discuss it later, but yeah. So what you see here is the message which was set in your controller. Okay, so before you set the model, right, you can even call some other methods. Okay, some different classes, different methods here. So this acts like a controller or a managed pin, and you can call different service methods from the controller. Here it's a very simpler thing. So that's how you see the value that was set in the controller. Hello Spring MVC from framework from hello controller in the message, and then you see message here. Okay, so this is all about today's week. You got 2 weeks break. So come prepared with your demo projects for your assignments. And if you have any other questions, you can ask, or yeah, we can disperse. Just make sure you go through this document for your richer understanding. Okay, cool. Thank you very much.
Thank you.
Yep, thank you.